Well, I'm definitely playing multiplayer with her because she bought it for me. And if she bought it for me, I probably should try playing with her, but I'm gonna play it by myself first.
Yeah, Ryan.
Sounded like a very personal comment there. Not digging in.
You buy him a game or what's
I bought Ryan Terraria and he hasn't played with me.
I played with you, Sam.
Like once, 10 minutes.
It was longer than. That's because it wasn't. It didn't work.
What do you mean it didn't work?
Team Uploader didn't work.
Oh,
Were you trying to play Rocket for your first playthrough?
he
No, I'm over.
He knows it.
I wasn't like Team on mobile. Mobile's better. No, but
I hope you have a
Team
great
Uploader
weekend,
is
Tegan.
Thank you. You too.
All right. Cotangent. How does it compare to the original?
Oh shoot.
I mean, it looks almost exactly like it, but what's the two big differences between tangent and cotangent? It swoops the other way. This one looks like it starts if you're going left to right. Look at me. It starts from the top and swoops down. The other one starts from the bottom and swoops up, right? That's one difference. What's the other difference? The asymptotes have moved. Now they're at pi and 2 pi, 3 pi, 4 pi, etc. Everybody understand? Great. All right. Let's go to the homework. Well, actually, let's take some quick notes. Open up your notebook. Tangent, cotangent. What is today? 12:1, but I mean, like, what section? I think it's 6.
0.5.
Is it 5? Did we just do 4?
Yeah, we did 4 yesterday.
6.5, tangent and cotangent graphs.
Yeah, that's 5.
Thank you. I understand the face you just made. I've said 12:1 1,000 times today. Sandy's teacher the other day was like, "Oh, did I tell you that in the Thanksgiving, thankful for you, he wrote about the boil blankie? Did I tell you about that? I'm so thankful for my mom, except for when she says that she's gonna throw my whale blankie in the garbage like she did the other day and made me cry." And I'm like, cool. He's told his teacher about it. He told his special ed teacher about it. They've both talked to me about it because they think it's very funny. And I promise you, that he went to school today and said, "Last night, my mom got shampoo in my eye and it reminded me," and like, all right, 6.5, tangent and cotangent graphs. Everybody write this. Y equals a tangent, parentheses, bx minus c, parentheses, plus d. Looks very familiar, don't you think? A is not the amplitude. Remember, there isn't an amplitude. A, if it is a number greater than 1, so if A is greater than 1, it gets steeper and steeper. It's almost like if I took this line, I'm going to let you write first. Okay, look at this. Can you imagine that this is like a string right here? Everybody imagine that? Everybody, are you using your imaginations? I know you are. I can see it in your face, Wyatt. You look like you're using your imagination hard today. Okay, so if I grab this string here and here, everybody look up. Imagine that it's tied in the center, and I pulled it tight. Can you imagine that it would really kind of straighten out almost? Like it would start getting like steeper and steeper. So instead of being curved like this, it would like kind of start going more like that. Yeah? So it gets steeper and steeper the higher your asymptote. If you have an A that is less than 1, but still greater than 0, then it is, I don't know, flatter?
Wider. Actually, not wider.
Less steep.
Closer to the x-axis? Closer to The center? Flatter? Go ahead, you can. Push the bottom drawer in. I feel like this is,
More gradual.
yeah, this is my life at home and at school, where I have like kind of like broken everything, where people are like, I can't make this work, and I'm like, oh, you just have to do this, and then it works. Let's do an example on your calculator really quick. Everybody go to y equals. Put in tangent of x.
Would you call that rate of change?
Sure. Yeah. It is less. The rate of change is less. You can't call it slope because it's not consistent, you know. But so tangent of x. Then I want, well, actually, let's just start there. Let's go to the window. I want to increase the y to -3 and 3. But I've still got it as yesterday's, or whenever last time we did this, 0 to 2 pi, 6.28. You should have it in there. All right. If you hit graph right now, you can see your tangent graph. Zip, 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 zip.
I don't know what the rest.
Oh, going back to the window. 0, and then 2 pi. I think the x scale we had was pi over 2, wasn't it? Yeah. And then y minimum is -3, y maximum is +3. And you graph it. It looks like this. Calculators used to be so old that they'd have a line going from the top of this one to the bottom of that one, like an Etch-a-Sketch. Like if you ever played with an Etch-a-Sketch and you like draw a house and then you want to draw a sun and you have to have like a line going up to the sun, and that's because old calculators were extra stupid. This is just mostly stupid. So now what we're going to do is we're going to graph another one, go to the y2, and this time I want you to write 8 tangent of x. Graph it. Wow, that one's so steep that it even looks like it's just a diagonal line. Maybe we should change it to something so you can really see the curve. Change it to like 4 tangent of x instead. Still looks like a diagonal line. But I promise you, it is curving. It's just our pixels. Let's try 2.
2 works.
2 tangent of x. So there's our original tangent graph. And here's 2 tangent of x. See how it's just tightening up a little bit? It's getting a little steeper. All right, now let's change it. Everybody go to your third spot, and let's put in 0.25 tangent of x. So my graph now says tangent of x, 2 tangent of x, and 0.25 tangent of x.
Oh, they clicked rating.
See how that one looks flatter? Okay, everybody understanding what A does? Great. B, instead of, do you remember how the period used to be for cosine and sine? It was what? 2 pi over b, but the period isn't 2 pi normally for tangent, so what would it